Good evening. In today's session, we are going to discuss on link budget design. This is also a continuation in mobile radio propagation. This link budget design is an approximation method so as to consider the loss and gain involved during the transmission of a signal in the path between the transmitter and the receiver. So this is a drawing which represents a simple wireless system where the power has been recorded. The transmitter radio sends the waveform through a cable and it has been forwarded to the antenna section where it gets radiated in the space. During its travel from the transmitting antenna to the receiving antenna, it experiences a path loss due to the obstacles or interferences or due to external noise. The receiving antenna receives the transmitted signal and again it is conveyed to the cable to the receiving section. There it is being processed and noise are being removed and it will be converted to the fruitful wave. In a wireless communication system, the link margin, it is always measured in decibels, is the difference between the receiver sensitivity and the actual received power. 15 dB link margin means the system could tolerate an additional of 15 dB of attenuation between the transmitter and receiver. That is, it bears that much amount of noise or loss that has been encountered during the path of transmission, and it still work better. It is typical to design a system with at least few dB of link margin to allow for attenuation that is not modeled elsewhere. It is very difficult to design a system with minimum link margin. A system with a negative link margin would mean the system is insufficient to transfer data. That is, if the link margin is above some zero value or a minimum value, then there is a good transfer of waves from transmitter to receiver without any loss. If it is less than 0 or if the link margin is in the order of negative value, then there is no meaning for a transmission of waves from the transmitter to receiver. It is of a vain. When designing a complete, that is end-to-end radio communication system, it is necessary to calculate what is termed the link budget. The link budget enables factors such as the required antenna levels, radio transmitter power levels, and receiver sensitivity figures to be determined. By assessing the link budget, it is possible to design a system so that it meets its requirements and performs correctly without being over designed at extra cost. That is important. So as to rectify the existing drawbacks, it should not be exceeding the limits and at extra cost. It has to be taken care. What is link budget? Linking, as the name implies, it is nothing but some connection or considering. Link budget is accounting of all the gains and losses during the transmission system. In essence, the link budget will take the form of the equation received power is equal to transmitted power plus gain minus loss. It has considered all the things, power, gain and loss. Where the losses may vary with time to time, depends upon the fading, depends upon the distance, depends upon the obstacles and many other factors. It must be made within the link budget. Thus, losses has to be restricted within the allowable link budget. For this, the worst case may be taken, or alternatively an acceptance of periods of increased bit error rate or degraded signal to noise ratio for analogous systems. Link budget equation. This is an equation that has been devised to investigate all the areas where gains and losses may occur between the transmitter and the receiver. Although many guidelines and suggestions are considered regarding the possible areas for losses and gains, each link has to be analyzed on its own metrics based on the ambient or the environment where the transmitter and receiver has been placed, and that also plays an important factor so as to decide the link budget or link value. A typical link budget equation for a radio communication system may be like this, like PR of K receiver is equal to transmitter plus transmitter gain plus receiver gain minus the loss due to the transmitter, and loss of receiver and other losses also. So the legends of all the parameters are mentioned here: free space loss, transmitter feeder loss, and other losses. For the sake of shadowing losses in the link budget equation is minus, actually the loss in figures of transmitter loss or free space loss should be taken as the modulus of the losses. Next is RF link budget. This is nothing but the link budget equation where the path loss is proportional to the operation frequency f squared. N is equal to 2 in free space. Path loss exponent that varies from 1 to 6 depends upon the environment. The antenna's height is inversely proportional to the operating frequency. Effect of multipath propagation. What do you mean by multipath? Single path is nothing but direct line of sight. Multipath na ground reflected path and direct path. Like this, many paths can be formed during the transmission of signal from transmitter to the receiver. This is termed as multipath. For true free space propagation such as encountered for the satellites, there will be no noticeable reflections and there will be only one major path or a dedicated path. However, for commercial systems or terrestrial systems, the signal may reach the receiver through number of different paths as a result of reflection, diffraction, scattering, etc. That will occur as a result of the objects around the path. Buildings, trees, objects around the office and home can cause all the reflections that will be resulting in the signal variations. The multipath propagation will cause variations of the signal strength when compared to that calculated from the free space path loss. If the signals arrive in the phase with the direct signal, then the reflected signals tend to reinforce the direct signal. Then the resultant signal will be the sum of the direct signal and the reflected signal. If they are out of phase, then there will be a cancellation of the signals. Therefore, the resultant wave will be the difference of those two signals. If either the transmitter or receiver moves, then the signal strength will seem to vary continuously and the relative strengths and the phase of the different signals changes. In order to allow for this, in a link budget, a link margin is added into the equation. Link budget calculations are an essential step in the design of radio communication system. The link budget calculation also considers the losses and gains to be seen, and devising a link budget enables the appropriation of losses, gains, and power levels to be made if changes need to be made to enable the radio communication system. Only by performing a link budget analysis this is possible. We have to consider all the losses or gains that has been encountered during the transmission of the wave between the transmitter and receiver. So this is the significance of link budget design, why it has to be considered for analysis.